Hi everyone, I continue on the lesson. This is topic 6, video number 2. So we learned that if I have an exponential function and I just don't have the equation and I just have the table of values, I can graph it on semi-log paper. I know how to graph it, and I learned that, and I learned how to make the equation. So now I want to use it in this example. Okay, so the example number 1. So for example, I give you this table of data, and so for this table, you don't know the equation, but you want to make the equation. Okay, so let's compare with here. Okay, so this is n0 here. So I told you n0 is for t equals 0. Okay, so n0 is here. If I don't have it, I can find it. I can show you in one example. Okay, so that's n0. So then you find the slope. Okay, what is a slope? A slope is logarithm 96. I said, okay, use the first point and last point. That's the better option. This divided by 5 minus 0. This is 0.3010. Okay, and then I can say, okay, so look at the thing I have here. See, I can say nt is n0, which is 3, okay, times 10 power 0.3010 power t. Okay, so you can maybe make it smaller and then right here bigger. Okay, so just with okay, so nt is 3, 10 power 0.301 that, and power t. Okay, so what is the answer? So when I use that, it is 3 power 1.999. Am I right? Yes, power t. Okay, and then if I say, okay, I want you to round it, so this is almost 3 to power t. And if you use, for example, t equals 0, yes. If I use t equal 1, yes, it is 6. If I use t equal 2, yes, it is 12. And yes, I see it works. So this is the equation. I found it. So for this part, I use this. And for this part, I use 10 power slope. And for a slope, I use this formula. Logarithm of one item, y, minus logarithm of another y, divided by x minus x. Okay, x2 minus x1. Okay, and then that's it. I have the equation. So if I don't have the equation, I can do that. And I also can graph it. Again, for t values, it is linear. So I can do whatever I want here. Here I can do 2 by 2. Here I can do 2 by 2. Here I can do so 1 by 1. I can do 3 by 3. Yes, this is t. And this one is log nt. That side, y-axis. But remember, you use the same amount, so the same value you see, not logarithm. The paper itself is doing it. Okay, so 1, 2, 3. Okay, this is from 1 to 10. This is from 10 to 100. That's it. I just need 2 cycles. Oh, okay, 10 to 100. That's it. So 1, 2, 3, 4, 5, 1 by 1, and then 10 by 10. So this is 20. Okay, so 3, 1 and 3, so it's here. 0 and 3, sorry, 1 and 6 is here because this is 6. 2 and 12, remember, 10, the next one is 12, sorry, the next one is 20, so 12 is just here, just beginning. Okay, just not beginning, I mean very small, so close to 10. Okay, the next one, 324. 324 is between 20 and 30, almost in between, almost in the middle, almost. The next one, 448, almost close to 50. This is 50. So 10, 20, 30, 40, 50. Yeah, this one. And the next is just 100, so close here. Okay, you use the same value. Okay, the paper itself is showing you in logarithm, and that's why you can see all the information very well. Okay, now if I ask you, for example, what is the result if I have t 2.5? You find 2.5 here. Okay, then you go there, you find this, then you go here and find the value. Okay, it is very, very more accurate than if I don't have semi-log paper, which you saw it before. Okay, so if I ask you that. Okay, so for example here, if you remember, for this example I told you, for example I said, in the example I said, what is the value for t equal, what was that, t equal, so for example half or 3.5 for, okay, so for 3.5 what was the result? 3.5, 187. Okay, so I go, it was hard to see on the curve, but if I want to see it here, so I do 3.5, then I make a perpendicular line here, then I make it so like this, and then I make and then I make it just this here. Oh yes, it is 190 almost. 187 is the answer. Yes. Okay, so I can see it much better if I work on semi-log graph compare to what I do on another graph. Look at this. Here it was so hard to see. Look at this. And look at this part. So hard to see. Okay. Yes, I know it was close to 200, but what was the result? Okay. Here it's more so just more clear. Okay. So that's why I use semi-log. Okay. Now, how about this one? Oops. Okay, now I want to yes, okay, so yeah. Now I want to go to this. Now I want to talk about log paper. Log paper. So far I had exponential function, means t was in the power, but right now t is in the base. Okay. So why this is a power function? Because power is a number here. Okay, so that's why power is a number. So if I ask, okay, power is a number, because I see power as a number. That's a power function. Oops, what's going on really? This is really annoying. Oh my goodness. Okay, let me see, what did I do here? Yeah. Okay. Okay, so I guess it's annoying you as well. Okay, so the power function, because I have number in the power. Okay, complete the set of table, means I give you value and you calculate. Okay, 0, 0, 1, 2. If I do 3, 2 multiple, that's 18. 2 multiple 25, that's 50. 2 multiple 36, that's 72. Let me see. Yes. And 98, right? Because it's 2 multiple 49. Okay. So this is also not like the other one, which I go from 4 to 1000, but this one also is 100. And the power is just 2. If I have power bigger number, so it will be large values. Okay, so small values at the beginning and large at the end. Okay, so if I want to graph it this way, yes, look at this. This is also hard to yes, this is also hard to hard to also do the same thing that I wanted to do. Okay, for example, for example here I ask you what is y-intercept. Okay, so it is hard to understand y-intercept is 0. Okay, this is y-intercept, that's hard to see it. Okay, so here we didn't, let me see, we didn't graph it very well. Yes, it should be this way. Okay, yeah, and let me see, yeah. Okay, so now it says using your graph, find the number of cells at half and 3.5 hour. Okay, so half, you go here and you see, oh, it seems 0. How about 3.5? Yes, I go here and I find this, and then I find this. Oh, I know it's between 20 and 40, but still it's hard to see. Okay, so what should I do? Okay, in this case, I have the equation. The equation is here. 2, okay, nt 2t squared. Okay, so that's that. Here I know, here I know the equation. So what can I do here? Okay, so what is y-intercept? I use this and I know it is 0. Yes, because when I put t equals 0, nt is 0, n0 is 0. Yes, but if I don't know the equation, that's hard to say from the graph. Oh, okay, so here. How about this? Okay, how about for half and 3.5? Okay, so I can use my calculator. So 2 this and 2 multiple this. Okay, this is the answer. So half is here and 24.5 is here. Okay, so what is the time that nt is 12? Oh, okay, so I have 2 t squared equal 12 means t squared equals 6 means t is radical 6. Because t is time, I cannot say plus minus because t is time. So it cannot be negative. Doesn't make sense. Okay? Excuse me. So the other one, 2t squared is 75. T squared is 37.5. And t is radical 37.5. Okay? So this is 2.45 and this is radical 37.5. Where is my calculator? I can find the answer. Lovely. Yes, which is 6.12. 6.12. Okay, here I have the equation. I can find the answer. Okay, using your graph, extrapolate the number of cells at 8 hours. Okay, so means you go to your graph and see, oh, okay, so I want the answer for 8. Oh, okay, so I have to continue to see what's going on for 8. That's also not easy. It's not easy to do that. Okay, so but I like to use my calculator. I like to use my equation. Okay, so it is 2 times 8 squared, which is 2 times which is 1 to 8. Yes, it is 1 to 8. The answer, number of cells. Now describe the curve. So the curve, if I have a large power, and if I have, just 1 second, if I have a large power and if I have for example, a large coefficient, okay, which is beside it, a large coefficient beside it, then I can see, yes, the graph increases quickly. Okay, so the graph is increasing quickly. Okay, so just 1 second. Okay, so this one, in this case, which is t squared, I have kind of parabola, just part of parabola, because t is positive. So instead of, for example, instead of this, I just have this part. Okay, but still it is a curve. Okay, still if the power is large, for example, t power a large number, if the coefficient is large, still I start from 0 because t power, so 0 power any number is 0, and then it goes to a large number. Okay, so on linear paper I have curve, that's a curve, and I want to make it like semi-like paper, I want to make it like line, because it's easier, and it's easier that I can read it. Okay, so what should I do here? So I'm going to show you here. Okay, let's work with this example. This is nt equal 2t squared. What is log of both sides? Log nt is log 2t squared, which is log 2 plus 2 log 2. 2 log t. Oh, okay. I have log n equal log 2 plus 2 log t. This is like x. This is like y. And this is like y-intercept. Okay? So, I have log for x and y, both of them. Okay, so I cannot go to semi-log paper. I can go to log paper. So if I have exponential function, t power a number, I go to semi-log. In this case, when I have power function, I can go to log paper. Because look at this. Compare this with the other one. The other one, t was released, but right now t is inside log. So domain and range, input and output, both of them are logarithm. So I use log paper. Means I use something like this, which has logarithm on both parts. Oh, okay. So it is 1 to 10, for example, 10 to 100, for example, 100 to 1000, 1000 to 10,000, for example, based on your need. And here 1 to 10, 1, 1. So 1, 1. None of them starts from 0. Remember. 10 and then again 10 to 100 and then 100,000 and then 10,000. So the same. It goes 10 by 10. 1 to 10, 1, 2, 3, 4, 5. Then 10, 20. Then 100, 200, 300. Then 1,000, 2,000, 3,000. Okay? And remember, it doesn't start from 0. No, both sides start from 1. Okay? So, now, here, the same as the other. I have the equation. So, I can fill the table. I can graph it on semi-log paper. Yes. But then I want to show you, if you don't have the equation, how can you make the equation? Okay? So let's here just graph it. First I show you how to graph, and then 0 to 18, 50, 72, 98. Okay? So look at this. Here I cannot do whatever I want for x-axis or y-axis. No, I have to continue the same way. I have to do. Okay, what do I need? Okay, here I need 1 to 10. Here I need 1 to 10 and 10 to 100. I need 2 cycles. I need 1 cycle for x and 2 cycles for y. Okay, the first one is 0 and 0. You don't show it because you cannot show 0, 0 here because it's log paper. It starts from 1 on both sides. Okay, x-axis, both y-axis. Okay, so this is t, this is nt. Okay, right? Now I start. Okay, so I do. The paper itself is showing me logarithm. Okay, but I use the same value I see in the table. The nature of the graph gives me logarithm on both sides, but I'm using the same values. Okay, so the first one is 1 and 2. Okay, so this is 1 and 2. This is 1 and 2 because this is 1 and 2. Okay, so 3 and 18. Okay, so 3, 1, 2, 3 here, and 18. 18 close to 20. 10, 20. 5 and 50. So 5 is here and 50 is here because it's 20, 30, 40, 50. 50 is here. The next one 72, so 50, 60, 72 is here. Okay, and the next one 7 and almost 100. Okay, so I use the same values. I show it on t x-axis input and nt y-axis output, and then I see it's a line. If it's not a line, I made a mistake, and then it's easier to answer question. It's easier to answer question. If I ask you, for example, what is value, for example, let's say, okay, what is value for 8? What was the question? For example, if I have 8 hours, how many cells do I have? For example, I can go here. Okay, and I can see, okay, so what is the value for 8? So I can see the answer here. Okay, so I can, for example, this is let me see, 5, 6, 7, this is 8. Okay, so I can just make this go up, and then I see where do I touch here, and then I do this, and then I know, okay, 100. The next one is 200. Okay, so I know, oh, okay, it looks like 120 something. Okay, which was the answer. I saw the answer there. Okay, or if I say, how about for 2? Okay, I can find the answer. Okay, so this is 2. For example, I go here, 2 here. Look at this. I say 2, and then I see here, which is 8, for example. Okay. Yeah. Yes. See, if I have 2t squared, if I say, okay, t is 2, I don't have the equation, but I just have the data, and I just have the graph. Then I say, okay, if t is 2, what is nt? You say, okay, t is 2 is here, and then I go here, and then I check here. Oh, looks like 8. But look at here, n2, which is 2 squared. Yes, it is 8. Yes, I can answer. But if I use the curve, if I use on linear paper, it's hard to answer. But when I use log-like paper, it's more clear to see. Okay, I can find. So I say, okay, what is the value of nt for 2 hours? You say, okay, I can go to do the graph and find it. It's more clear than the graph, which is the curve, which is not on log-like paper. Okay, so, and we did it here as well. Okay, yes, the shape on linear paper, yes, it is a curve. On log-like paper, it's a line. So curve here and line here, so it's very clear to see. Okay, so now I want to see how can I make the equation, because I told you, not always I do have the equation. So what should I do? Okay, so now I do it here. Okay, so logarithm of nt is logarithm 2 plus 2 log t. Okay, yes. So what is 2 here? 2. Okay, so, okay, I go to the table. I see 2 is for value equal 1. Okay, so this is the value that I have to use for t equal 1, not 0. Okay, because here this is my y-intercept, right? Okay, so this is for t equal 1. I can use this value. Oh, okay. So how about for the rest? What should I do for the rest? How can I find, for example, this value, for example? Okay, what should I do? Okay, so let me show you here. Show you on this here. Okay, so if I have this equation, okay, yes, I can use my equation to find the result. Yes, 2, 18, 50, 72, and 98. Yes, and I say, okay, I do not use this part, okay, on any calculation and on the graph. Okay, so what should I do? The same as the other one, I need to pick 2 points. Okay, based on my experience, I say use these 2 points. The one the first one, which is not 0, 0, which is not for t equals 0, and the last one on the table. Okay? Then find the slope. The slope is log, change on log of y and change on log of x. What is the slope? A slope is y2 minus y1 divided by x2 minus x1. But for log paper, I have logarithm for both of them. So I have to use this. Okay? You have y-intercept. Yes, y-intercept equal that. Okay? Right? What is y-intercept? Yes, I said for y-intercept use this value. Okay, so this value for t equal 1. So for t equal 1, find n1 on table. This is your y-intercept. Then write the equation. Okay, write the equation. Logarithm n equal logarithm n0, but I don't say n0, I say n1 because, okay, and we call it n1. n1, this is n1 because I use it for t equal 1, not t equal 0. Okay, so logarithm n1 plus a slope that you have here, which is m. This is m. That's m here. Multiple logarithm t. Then you do 10 power logarithm. 10 power n equal 10 power logarithm n1 plus m logarithm t. Very similar, I can say it is n nt 10 power logarithm n1 multiple 10 power m logarithm t. Okay? Then very similar, I can say this is n1 because 10 and logarithm are coming beside each other. They are inverse of each other, so they cancel each other. n1 multiple 10 logarithm t power m. Do you remember? I said this can go here. Yes. And then in this case, I can say n1 t power m. What is m? M comes from here. What is n1? Is it from here? Okay, perfect. I can write my equation. So if I don't have the equation, I can use the table to write my equation, which is here. B is n1. Remember, it's not for n0 because I do not have 1 on the log paper. This log 0 is not defined. Log 1 is 0. So I use n1. I do not use 0 and 0. That, and m is logarithm of y2 minus logarithm of y1 divided by m is logarithm of y2 minus logarithm of y1 over x2 minus x1. Yeah. Yes. Here I didn't want to confuse you, so I didn't say. This is like a slope here. Okay? This is like a slope. So it looks like the equation of the line. Okay? So this is like, for example, x, but do you remember it was mx plus b? So this is like x. The reason I have log t because I use log on x-axis and y-axis both together. This one is like a slope. Okay? I didn't say here because I don't want to confuse you. This is like a slope. Okay, so I need to do changes on y over changes on x. Changes on y is changes on logarithm of y because I have log for both of them. And changes on x is logarithm for that. Okay, so it's logarithm y2 minus logarithm y1 over logarithm x2 minus logarithm x1. Okay? Yeah. Again, this is one example. You can do it, and then I can show you this paper here, which has all the rules here, and then we can go to practice question. Okay, so let me finish this. Okay, let's say I do not have my equation. I just have this data, and I know it's log. Okay, so I know it. Okay, so I use this part. This is one of the main point that I need. T equal 1 and nt. Oh, good. So m logarithm 686 minus logarithm 2 divided by logarithm 7 minus logarithm 1. What is the result? The result is 3. 3 is the result. And remember, this is 0. This is 0. Logarithm 1 is 0. Okay, this is 3. Oh, okay. So the answer is nt is 2 t power 3. 2 t power 3. That's it. That's it. I did it. So for log paper, I know what to do. For that one, I know what to do. Then I use my information here just to graph it. Okay, so for this one, I need one cycle, which is 1 to 10. Remember, you do not use this part because you just have one cycle on x-axis. For this, you have one cycle here, one cycle here, and one cycle here. For this one is 1 to 10. For this one is 10 to 100. For this one is 100 to 1000. So 1 to 10, 1, 2, 3, 4, and 10 to 100, 10, 20, 30, 40, and then 100, 200. Okay, so let's find the answer. So 1 and 2 is here. 1 and 2 is here. 3 and 54 is here. 3 is here. 1, 2, 3, and this is 54. So 10, 20, 10, 20, 10, 20, 40, 50, 10, 20, 30, 40, 50, 54 is a little bit in the middle. 54 is between 50 and 60. The other one, 5, 250. 5, this is 100, this is 200, this is 250. Because it's middle of 200 and 300. It's a middle. 6, 4, 32. It's not in the middle, a little bit under middle. Okay, so this is 100, 200, 300, 400. This one is 400, and the next is 500. And the last one, almost 700. So almost here, almost 700. Okay, so you find all of those on T and NT. But you are using log paper. You can see everything more clear. Now, if I ask you what is the result, for example, for t equal 2, for example, you don't see it here, t equal 2, you can go here and say, okay, so t equal 2 must be close to 20. Okay? Right? I can do that. Now, I can show you all here. Semi-log and log. Okay. Semi-log is here. Semi-log paper has horizontal, linear, x-axis the same as before. And equal spaced. Vertical is logarithmic. You use t and nt to plot, and the paper itself is doing logarithm on y-axis. Then you pick 2 points. You use log for y and not log for the t, no, just for the top. You use y-intercept, and then you use it here. Okay, log paper, this is the second type. The first one is for exponential function. See, here t is in the power. T is in power. But the other one, no, t is in the base. T is base. That's power function, which you saw before. Okay, so log. For log, you have log paper. So you have on horizontal and just vertical, all of them. You use them to plot them. Don't use logarithm. No, you use both, all the values the same as the table. Then you pick 2 points. Then you calculate this slope. You use nt, but for t equal 1, not 0. Make sure don't mix it. Don't mix semi-log with log. And then you write the equation. This paper can be your reference. Okay, so do practice on it. Okay. So I stop here and then I continue in the next video. So video number 2. I just continue in the next video. Thank you so much. Bye.